Okay. Regulation of buoyancy, exercise 3.2.2 or exploration 3.2.2. So, hopefully you notice that when you squeeze in the sides of the bottle, you see more liquid filling up the stopper, the dripper, whatever it's called. So eyedropper. So if this was my original, then when I squeeze in, I see more fluid go up into the stopper. Now, no air has gone into or out of the stopper. So if this is stopper originally, I know that my air particles are going to look like this. But then when I squeeze, I can physically look at the eyedropper and I see that they're going into a smaller, I've got the same number of particles, 1, 2, 3, 4, 5, 6, 7, 8. I've got the same number of particles, but they are squeezing into a smaller volume, which means they become more dense. So same amount of air, in a smaller volume. And so as the density increases, the density of the water is actually outside the bottle is staying the same. While the density of water is staying the same. So the density of the air is increasing, which means it's going to sink. Hopefully you got that when you were thinking about it. So answers, number 1. So as pressure increases, so we know, so we're going to look at the ideal gas law, PEV equals nRT. And we know that as the pressure increased, in order to keep the number of particles the same, and we know the temperature is not changing, that means the volume has to decrease. And so the buoyant force is reduced while the force of gravity remains constant. So if we think about the forces acting on the eyedropper, we know that we have the weight going down, which is force due to gravity, and we have the buoyant force going upwards. But that is going to be less because the volume is less, and so the eyedropper is going to sink. So number 3, that was 1 and 2. Number 3, submarines dive by allowing outside water into the ballast tanks. And so by releasing compressed air into these tanks, the water is forced out, causing the submarine to rise because the buoyant force now exceeds the submarine's weight. Okay, I need to figure out where I put my answer to the rest of this. Oh, wait a minute, I got it. Number 4, using giant aquariums and specially designed neutral buoyancy suits, astronauts are able to experience a weightless environment here on Earth. So basically they go into a gigantic pool.